Hey there, welcome or welcome back. When we talk about GitHub security best practices, I want you to think of this module as your guide to building more secure software without adding unnecessary friction to your workflow. My name is Peter Detender, a lead technical trainer here at Microsoft. In this section, I'll walk you through the idea of code scanning, what it actually does behind the scenes, and why it matters for the way you write and ship code every single day. You'll hear me later on refer to CodeQL, GitHub's powerful analysis engine, as well as Dependabot, a vulnerability package scanning engine. By the end of this module, you'll have a clearer picture of how these tools support the secure development lifecycle and how they fit naturally into your existing GitHub workflows. In this part of the course, I want to give you a practical view of how GitHub helps you build a secure development foundation. As you work through this module, I'll show you how different security features work together to protect your repositories. You'll see how to apply best practices like setting strong repository policies, enabling code scanning, and configuring automation that reduces the manual effort involved in keeping your code safe. Think of this as your first step towards building a proactive rather than reactive security mindset. Instead of waiting for issues to surface later in the process, we're going to focus on integrating security right where you work, inside your GitHub workflows. As we go along, you'll notice that these practices are not just for large enterprises. So whether you're part of a small open source team or working in a large DevOps organization, the same principles apply. You'll learn how GitHub Advanced Security unlocks capabilities like automated scanning and third-party analyzer integration, and I'll help you understand when to use which option. By the end of the module, you'll not just know what GitHub can do for you, but you'll understand why these features matter and how they fit naturally into a development lifecycle you already use. When we talk about establishing a secure development foundation, I want you to imagine security as something that lives inside your workflow. It's not something that gets bolted on at the end. Many teams assume developers already understand what secure coding looks like. But in reality, security knowledge can vary widely, and the threat landscape is changing constantly, right? So, part of building this foundation is simply acknowledging that security is shared responsibility. It's also why early awareness, training, and standardized best practices are essential for minimizing risks before they escalate into larger problems. Another big theme here is shifting security left in the development lifecycle. Instead of waiting until the deployment stage to run scans or checks, modern DevOps practices allow us to run them early and more frequently. This shift helps you catch issues when they're easier and, more important, cheaper to fix. GitHub contributes to this by providing tools like Dependabot, security advisories, policy files, and workflows that integrate seamlessly into your day-to-day coding activities. So by the time we finish this segment, you'll have a much clearer picture of how GitHub keeps security visible, accessible, and again becomes part of everyone's job, not just the security teams anymore. Now let's take a closer look at what it means to maintain a secure repository in GitHub. A lot of this comes down to putting the right guardrails in place so your team can work quickly without exposing your organization to unnecessary risk. For example, having a clear security policy gives contributors that structured way to report vulnerabilities in a responsible way. Using features like private security advisories allows maintainers to collaborate on fixes behind the scenes before anything becomes public. These might seem like simple steps, but they dramatically reduce the risk of accidental leakage or mishandling of sensitive information. We also need to think practically about protecting data inside the repo. Misplaced secrets are one of the most common sources of breaches, so relying on Git ignore files and strong removal procedures is really essential. On top of this, features like branch protection rules, mainly force requiring reviews, passing checks, or successful tests, ensure that only vetted changes make their way into critical branches. And as you learn how these pieces fit together, you'll see how they create a workflow that again encourages consistency, accountability, and a culture of shared security responsibility. In this section, we're shifting our attention to automated dependency management using GitHub Dependabot. Dependencies are a normal part of modern software development, but they also introduce potential risk. As new vulnerabilities are discovered, it can be overwhelming to manually keep track of which libraries need updates. That's exactly where Dependabot comes in. It monitors your dependency graph and cross-references known vulnerability databases to automatically alert you when something requires attention. Now, what makes Dependabot especially powerful is that it doesn't stop at just notifying you. It can also create a pull request to apply security fixes for you, allowing you and your team to focus on reviewing and merging rather than hunting down version patches. This workflow helps you keep your environment secure with minimal operational overhead. And you'll see later on how this automation fits naturally into your development lifecycle, as well as how it supports a proactive approach to supply chain security. Before we dive deeper into other security automation aspects, I want to give you a quick preview of what the dependency management demo will look like. In this demonstration, I'll show you how GitHub provides visibility into your dependencies using Dependency Graph, how Dependabot detects and surfaces security issues, and then how the Dependency Reviewer action helps you assess the impact of changes introduced through pull requests. The main goal, as always, is to show you how dependency management becomes a natural part of your coding experience, rather than this separate time-consuming process. So for my Dependabot demo, allowing you to get some idea what it actually means to have that dependency vulnerability scanning, I decided to do maybe something a little bit weird. What I mean by that is, I'm going to use one of my sample repos from my other course that I recorded a few weeks ago on GH-900, which is the Advanced GitHub Security. Now, why am I doing this? Because I think, first of all, I already had everything in there because the GH-900 is like a full class on GitHub security best practices, where now this is obviously foundation level and a pretty shorter module. And instead of like rebuilding everything, I was like, well, what if I just try to tease you with just a little bit, like keeping it foundation level, and then also maybe inviting you to already have a little look at that public open source available sample repo that I have. And it's going to be the same for my other demos in this module as well. What's important here, it's sample code. So what we're going to do is just showing you a few of the options, the settings, but not really going deep dive how to configure everything. Although actually it's not all that hard. But there's still a difference between watching this foundation level or going through the full GH-900 course. That's the main message. So starting with Dependabot, you navigate to your repo. And obviously this Dependabot is just the name for my repo. You navigate to the security tab and you're going to enable Dependabot. From there, it's going to run a scanning task for typically a couple of minutes, and after a couple of minutes, it's going to show you the results. If you don't have any package vulnerabilities, then obviously it's not going to show you anything. But in this case, just as a simulation, it's going to show me like, well, based on your code base, we detect 4 issues. Where obviously now for you as a DevOps engineer, developer, maybe security engineer, your task is going in through Dependabot, validating what's happening, but also what's the recommendation. And that's really, as I mentioned, as part of the presentation, it's not just about detecting, not just about scanning, but also giving you the recommendation to mitigate the security risk. I'm just going to grab one of these because it's not about the security specifics. It's about really showing you the capability of Dependabot. So in short, got my repo, enabled the Dependabot vulnerability scanning, waiting a couple of minutes and getting the alerts. Where then from here, it's going to highlight the actual problem. So this is a package that I'm using in my sample Ruby code or JavaScript code or Java or .NET or any other. All frameworks are supported. And it's going to tell me like, well, the problem here is because you're using an outdated package where the package has known vulnerabilities. Now, how does it work? Behind the scenes, it's running what we call the CVEs. Now, CVE is an open source project that's going to report, like, think of it as a database, right, of known vulnerabilities for each and every existing package across the globe. Next to that, so that's what you see over here. And it also provides feedback coming from the GitHub advisory security team themselves. There's quite some overlap. Every now and then there might be something detected by GitHub team that is not reported yet in the CVEs, like what we call the 0-day security issues. And that's where you might have a differentiator. Now, if we grab this number, and I'm going to navigate to cve.org. And I provide that number here, or just a number, it's going to show me more details and typically identical information. And that's in short, I would say, the real power of Dependabot, where it's bringing in the scanning mechanism, and I'll show you a little bit in a second what that means, but it's also based on information from that open source CVE project. The action item is another big benefit. So what that means is right now it's alerting like, hey, there is this problem. And apart from the alerting, it's automatically creating the pull request. My assumption is that you watched all previous videos. If not, I would recommend you to go through at least module 2, where we talked about GitHub integration, the pull requesting, the forking, everything like that. But in short, this is all managed by Dependabot. It scans code using GitHub Actions. After running the analysis, it's going to report the suggestions, and the reporting pay, apart from the alerting, is moved into a pull request. Where now the pull request is still following the baseline concept of a pull request on its own, not just for the security fixing, but it's going to highlight the recommendations, like what do we need to do to fix this security problem. It's going to rewrite code files, and then in the end, just like any other pull request, the idea is that you as the project owner, you're going to loop through, you're going to validate all the recommendations, and eventually when you merge the pull request, it means that it's technically overriding the code file that has the version numbering for this specific security problem. So just following all traditional GitHub practices, moving from the repo into a pull request, merging it, and all magically happening behind the scenes. I mentioned that it's based on actions. So after you again enable Dependabot for the first time, it's going to create a Dependabot GitHub action, and it's going to run the action for you. You can make these actions a lot more complex. You can integrate Dependabot as part of your own build process. So a lot of different options that, again, I don't think it's really foundational level, but you can think a little bit broader, maybe even more enterprise ready. Another example I want to show you here is the insights. So insights, I showed you this already in a different part of a demo where it showed you insights about the repo. Where now in this case, you can specifically zoom in on the dependency graph, and that's going to give you a more complete view of all the alerts, all the dependencies. It also allows you to export the SBOM, like the software bill of material, and that's where in the presentation we talked about like the serif file, where it allows you to export, maybe integrate information into like third-party scenarios. It's a JSON file that you can download, export, import in a third-party security monitoring management tool. That's the main idea. Last item I want to show you is back to Actions, where we have Dependabot, so basically doing the end-to-end management of analyzing security code, detecting, creating the alerts, interacting with the pull requests, running actions behind the scenes to do all this. But then we also have a specific GitHub Actions pipeline that we call dependency review. Dependabot and dependency review are not exactly the same thing. What is dependency review? You need to import this pipeline. And again, we're not talking about actions too much in the foundations course because it's becoming pretty complex, pretty fast once you start touching on actions. But I created one out of this GH-900, obviously. And what it's going to do is running the action, like literally triggering the tasks. And the outcome is list of alerts, obviously depending again on the state of your repo. And then from here, it's listing up all vulnerabilities. Now you might go like, okay, isn't this doing the same thing as Dependabot? Now the big difference is that dependency review is only running the analysis and showing you the report. It's not creating alerts apart from the reporting view. It's not creating the pull requests, and it's not only relying on that CVE database. So that's why we talk about this. The recommendation I could give you is enable Dependabot, pretty easy, pretty straightforward. And then optional, you could go through the reviewing as well. If you go like, well, I want to use the review just for the scanning, the analysis, but I don't want that pull request integration for any good reason, right? Then you don't have to use it. I think that's pretty much it on the Dependabot for now. So let's go back to the presentation because there's more security information to share. In this slide, it's all about CodeQL and how it powers code scanning inside GitHub. If you've never worked with CodeQL before, think of it as a way of analyzing your source code by really treating it like structured data. Instead of simply scanning text for patterns, it builds a semantic understanding of your code, allowing it to detect vulnerabilities with much higher accuracy. You'll use CodeQL both to identify existing problems, but also to prevent new issues from being introduced into your main branch. There are a couple of different setup options, starting from the default setup, using advanced workflow configuration, and then running CodeQL through external CI/CD pipeline systems, like, for example, Azure DevOps. Each approach has its own benefits, depending on how customizable you want your scanning pipeline to be. But also keep in mind that GitHub Actions billing affects code scanning usage, especially when working with private repos. I hope it makes sense for you how CodeQL fits into your broader DevSecOps strategy and how to choose the right configuration for your environment. CodeQL is specifically to GitHub and GitHub repos, apart from the integration with Azure DevOps. But GitHub provides support for enabling code scanning using third-party tools as well. GitHub allows you to upload SARIF or SARIF files, as we call them. Those are standardized security reporting files generated from external scanners so that all your alerts appear in the GitHub Security tab. This is extremely useful if your organization already relies on commercial or open source static analysis tools and you want a centralized location to review and manage results. This capability is especially valuable in enterprise environments that use multiple scanning tools and want to unify the security workflows under one single platform. So with that, I think it's time for another demo, in which I'll walk you through how GitHub code scanning works end-to-end. I'm going to start by enabling CodeQL on a repository so you can see how simple it is to get started. And then I'll show you how CodeQL actions behave in the detection of issues, annotating your code, and then helping guide you through that remediation process. And then lastly, I'll show you how to manage and interpret the results from scannings, including how to filter, prioritize, and track fixes over time. The main goal of the demo is to give you a complete picture of that developer experience, what you'll see inside GitHub, how alerts are structured, and how you can use this information to strengthen security of your pipeline. So for the code scanning, I'm going to use about the same as what I did for the Dependabot vulnerability scanning, where I'm going to reuse one of my other public repos, GH-900 code scanning demo, where again the approach is that I wanted to use this to just highlight some of the core features that we have, but not turning it into a full section on everything that code scanning can give you. But since I already had sample code, already have that sample repo, I just thought I'm going to reuse it. So what's the idea? About the same as Dependabot. You go into your repo, you navigate to Security tab, and the first time you need to enable the feature that you want to use. So we talked about Dependabot before, so not going to use Dependabot, but what we're going to zoom in here is code scanning. So initially, you might need to enable it on an enterprise environment. By the way, if it's a public repo, you have access to the capability by design. You don't even need to enable it. It's already active by design. I also briefly mentioned GitHub Advanced Security as part of the presentation. So what that means is if you have that GitHub Advanced Security licensing plan, your settings look slightly different because you have a separate configuration settings blade option here. So I can navigate to Advanced Security, and we talked about dependency graph earlier. We talked about Dependabot earlier. Then if you scroll down, that's where you find the code scanning section. I'm going to use CodeQL, so it's the built-in GitHub code scanning tool. But as you learned from the presentation, you can integrate third-party tools as well. Back to the top. So we enabled code scanning. It's creating an actions pipeline in the background, and I'll show you a little bit of that in a second. And out of that, after again a little bit completing the actions analysis pipeline, it's providing feedback. So in my imaginary code here, obviously purposely built to have some alerts, some security issues out of my demo, it's going to alert and telling me what's wrong. Now, emphasizing what's the main difference between Dependabot and CodeQL, again, Dependabot looks at the package vulnerabilities. Code scanning, as I explained before, it treats your repo as data. It allows you to search for information like security problems, right? Where it's not just looking at the vulnerabilities, although technically it could actually detect those as well, but now it's literally looking into the actual code level. So it's going to tell me here, well, somewhere in your repo, in this file, where in this case, it's somewhere in my JavaScript query, there is a little syntax in my code base that could benefit from security optimization. It's not looking at the package, it's looking at the actual code. That's a big differentiator. And then it's still a suggestion. So it's going to highlight an explanation, like this is the reason why there is a security vulnerability, and this is how you could fix it. Again, using a pull request as the main mechanism. So we can navigate to the pull request, and it's going to give me more details about my code base. Again, good old best practices out of GitHub, out of your repos, the branching, the pull requesting, everything we talked about, it's all available. the actions pipeline to run all this, and you don't need to build the actions pipeline. So when you enable CodeQL, it's going to create that pipeline for you. It's what I have over here, my CodeQL Advanced, which in the end is just a label. Now, again, although we're not talking about actions too much, you might think like, well, isn't this complex? Well, actually, it's not all that complex. Because what we need to trigger this action, like scanning code, is an action against your repo. So what I'm doing here is whenever there is a change, so the trigger here is on, that's like a bit of YAML syntax for actions. The on keyword is watching over when there's a trigger, I'm going to run a certain task, meaning running the GitHub Actions pipeline. And you can filter based on a specific branch, main or any other, based on operations like a pull request, creating an issue, anything like that, or like in this case, a scheduled task. I want you to run a task, and the main task is I want you to use the CodeQL scanning, where in this case, I want to use it against C# and JavaScript. C# could be my application backend code base. The JavaScript, TypeScript could be the front end, right? So you don't have to split up all those tasks anymore. It's going to check out the repo, which basically means it's going to run a Git clone from the repo into the GitHub runner. And that's the virtual machine running the actions pipeline. And then the magic, like super easy, is one line of code where you're going to bring in, you're going to trigger, you could say, the CodeQL action. And for now, we're going to initialize it. That's what we're doing over here. And a little bit further, you're going to run the actual analysis. So in short, and again, I don't want to detail too much on the actions, but I know out of like teaching about this for so long, I typically get those questions like, it all looks to like just magically function, but how does it actually work behind the scenes? So that's really what this part is about. You're going to initialize the actions code scanning task. You're going to run the analysis. That's where the actual security scanning happens. And then obviously based on that, it's providing the alerts and the feedback. So that's CodeQL in short, where since we talk about security, I actually want to show you something else that I didn't talk about in any of the other topics, because I want to keep like all security information in this one, is the repository rule base. So you navigate to your repo, and we talked about branches before, where now you can create a rule set. So what is a rule set? It allows you to protect your branch. Maybe you don't want to update the main branch. It's what we call in like DevOps terms, protecting main. So you can create a rule set, you can enable, disable, and you're going to define like, well, all these requirements, all these rules are basically coming from all the settings more below. Like maybe you don't want to delete branches. Maybe you want a reviewing process where maybe you have like 2 different reviewers before you can merge a pull request. And so many other settings, like I'm not going to read out all the options here, but the main scenario would be that you're going to create a target, including the default branch, or if you want, you could also use your naming conventions. In, I think, Module 2, we talked about GitHub repos, where I mentioned the main branch, typically other branches. And then from here, I also mentioned that main, although it's by design the default, you can actually decide that for whatever reason, but hopefully a good reason, another branch is now becoming the default. Now, out of my real world experience, I've seen so many issues where some of these rules are never getting applied to the main branch. Why? Because by design, as I showed you, you're going to highlight the default branch. So what I've been doing in all my production environments is, first of all, adding the default branch, but then also running like main or any other branch based on the naming conventions. And then from here, you apply those settings. And another way where we're emphasizing, let me take a step back, where we're emphasizing out of GitHub that you should look into the rule sets is this little banner up here. I have a branch, I have multiple branches in this scenario, I got 6 of them, and that's where now GitHub goes like, hey, we want to give you a best practice, you should integrate some rule sets to really protect your main branch. So we talked about CodeQL, code scanning, running the actions pipeline behind the scenes, and then extending a little bit on yet another security feature using the repo rule sets. I think I got a few other things to cover, so let's switch back to the presentation. Another aspect of securing your code is the focus here on user identity, authentication, and access management. Securing your GitHub organization isn't just about code. It's about making sure that only the right people get access, and actually the right level of access, where features like organizations, SAML single sign-on, and SCIM or System Cross Identity Provider Management provisioning helps you manage user identities and permissions at scale. All these tools together ensure that teams can collaborate effectively while still following strong security practices. Many enterprises use separate organizations to group departments, create product teams, or have business units. With GitHub's access management features, you can enforce consistent controls while still giving teams room to work independently. So by the end of this section, you'll understand how identity and role-based access tie directly into your broader security posture. This slide here takes our identity discussion a step further by looking at authentication methods like multi-factor authentication, using SSH keys, and using personal access tokens. As DevOps/developer engineers, many of us use these daily, but it's important to understand how they contribute to that overall security. MFA, for example, adds a critical extra layer of protecting your passwords. SSH keys and paths or personal access tokens control how users interact with Git with APIs, and these can be audited or revoked as needed. And again, remember, we also talked about repository access using public or private visibility, as well as the identification of collaborators and corresponding permissions. And as you could imagine, there's another demo upcoming. In this one, I'll show you what it looks like to manage user accounts inside GitHub, how to configure two-factor authentication or better authentication, and control repository permissions. We'll navigate through the settings that affect how developers authenticate, how administrators review access, and how organizational boundaries help keep your data secure. So, showing you a couple of things around like identity, user account management. Now, remember that my demo environment is probably not reflecting your enterprise environment if you're using enterprise, obviously. So some of the settings might look slightly different than what you have in your organization and enterprise level. But overall, a lot of the settings, I hope, will just make sense and shouldn't be all that different. So the starting point, obviously, is your GitHub account. So if I go to my profile, I showed you this in another part of the demo earlier in a different module, where you can see your profile and you can obviously customize all of this, but that's not really the security part of it. But you can validate if your account is linked to a specific enterprise environment. So the approach we use, like I guess a lot of you in your own organization, is using a personal account like peter@github.com. And then from there, you're going to link it to an enterprise organization level. You can get access to multiple organizations. So in my case, being part of Microsoft and working quite a lot with DevOps, it's mainly organizations and enterprise level that I'm using. If I navigate to organizations, it's basically doing the same as opening up my account, navigating to settings, and then over here, selecting SSO, single sign-on, and organizations. So what happens here is now that it's using my Microsoft corporate employee account, giving me access to the GitHub Organizations in the backend. So I still have my GitHub account, but then I'm navigating to Microsoft managed environments. You can join, you could maybe leave. It's obviously all depending on how your organization is using all of this. From there, we can use a few other options where you could create your own keys. So if you have like an application maybe running on, I don't know, like a Linux platform, you don't want to store secrets hard-coded. So that's where you could use SSH keys. And now you can use those directly from within a GitHub environment. Another example where you might need to use some identity is that personal access token. What that means is you're going to go into your account settings. You scroll all the way down to over here, developer settings. And then the one that I want to talk about most here is personal access tokens. So you're going to create some sort of a service account credential. And most important here is not just creating and accepting like all permissions, but the idea is that you're going to like create what we call a fine-grained token, which means that you're going to look into the documentation, preferably looking into all the different components within GitHub, and then specifically defining what permissions the service account here would need. So I could create a demo token. And from here, I'm going to link it to my account because I'm the owner. You can define the expiration. The best practice here is keeping it as short-living as needed. The token gets access to specific repos, maybe all public ones, maybe some private ones or individual ones. And then again here, most important, I would highlight is the permission model. There's a huge amount of options, so not just going to walk you through all of these, but you can define that, for example, you're going to use a token to maybe interact with the repo, but not interacting with actions. Maybe you want to use the token out of code spaces. Maybe you're going to hand over the token to GitHub Copilot, where Copilot can take more actions using the token than if it's using its own built-in security permissions. So those are some of the highlights. Last part is the repo permissions. I mentioned this in the repo management section in a different module, but since we're so focused on security in this one, let me take a step back to my account and all my repos. Where again, if you have public or private, already mentioned this multiple times, you can define collaborators. Now, this is my demo cats public repo, which again means by design, everyone on the internet has access to it. Technically, almost full access, like cloning the repo. Yes, they can contribute out of like the forking process, but we could still identify additional collaborators, which now means that although it's public, and we like that open source collaboration aspect, I could still invite other GitHub users to become like a contributor, but contributing in a slightly different way, where they got more access to managing pull requests, maybe managing issues, maybe approving merging pull requests. So adding, I would say, administrative level permissions to other GitHub users. That's what the collaborator step is doing. And then the last part is here the moderations, where again, it could be important for specifically open source to look into these details, where you got like 3 different levels: limit to existing user, limit to prior contributors, and limit to repository collaborators, where each and every of these, again, define specific permissions to the different levels of the contributors. I think that's pretty much it on my individual personal account setup. Know that a lot of this as a guideline, as a concept, is identical for enterprise, but then obviously you got more options. You're going to create teams, you're going to create groups, and you're going to define more granular permissions. That's all for now. So let's switch back to the presentation and wrap the module up. Before we wrap up, let's reflect on what you've learned in this module. We covered, first of all, why shifting left matters, how GitHub security features help you reduce risks early, and how tools like CodeQL, Dependabot, and repository policies all work together to protect your codebase. These security best practices aren't just for advanced security teams. They're meant to support every developer, DevOps engineer in writing safer, more maintainable software. And as you think about applying these concepts in your own environment, remember that security is a journey. It's not a destination. By automating checks, enforcing strong authentication, managing dependencies proactively, and continuously improving your workflows, you help build a security-first culture in your team and your broader organization. And as threats evolve, these habits will help you stay ahead of it. By the way, if you want to learn more about GitHub Advanced Security, I recommend you checking out aka.ms/GH-900 on YouTube. And then finally, I want to thank you for going through this module with me. Everything you've learned here, from coding scanning, repository protections, identity management, and secure automation, all those contribute to a stronger and more resilient development process. I encourage you to explore these tools in your own projects, experiment with configurations, and continue building your security skills. But also remember, there are several different ways to continue your learning journey. Whether it's following me to the next video in this GitHub Foundation series, or why not exploring aka.ms/learn to find your next learning path of choice. Take care, my friends, and I'll see you again soon.